Good morning friends and my dear students. Today I will be solving some of the problems in electricity, that is numerical problems. So there are high chances that you will be getting at least one of the problems from this chapter. So it's not just for marks. Even when you go to higher classes, most of the topics are based on electricity. For example, if you take magnetism, it is based on electricity. So if you are thorough in solving this, so you'll be able to solve, or it will be easy for you to solve the problems in upcoming classes, that is in 11th and 12th. So it's not difficult, it's very easy. There are only few formulas based on which you will be getting the problems. So the first question is, study the following circuits, find the current flowing in the circuit and find the potential difference across 10 ohm resistor. So the circuit what they have given is, this is the circuit where this is 10 ohm and 20 ohm. This is a 3 volt battery. So what we need to do is find the current. So the total current that is flowing through the circuit is, this is 10 ohm and 20 ohm. We know the equation for current, that is I is equal to V by R. So what is the value of V? So V, that is potential difference, what they have given as 3 volts. So R. So R in this case, it is a series circuit. So that is RS. So R1 plus R2. What is the value of R1? 10. R2 20. So it is 30 ohm. So I is equal to V by RS. So that is nothing but V. What is the value of V? 3 volt. So what is the value of RS? 30. So I is equal to 0.1 amperes. So don't forget to mention the SI unit. Then they have asked the potential difference across 10 ohm resistance. So this is the potential difference that we need to find. So let's take that as V1. While deriving the equations, or while deriving the expression for a series and parallel combinations, so you might have come across V1, V2, V3, and so I1, I2 and I3. So in a series, the potential difference across individual resistance is different. So the potential difference across 10 ohm is not the same as potential difference across 20 ohm. So because the current that is consumed in a 10 ohm resistance is different, whereas in a 20 ohm resistance is different in a series, that is in a parallel. Whereas in a series, the same current will be flowing across 10 as well as 20. If it is a 0.1 ampere, 0.1 ampere flows through 10 ohm as well as 20 ohm. But the potential difference is different because we know potential difference V1, that is I into R1, or in general if you take V is equal to IR. So from Ohm's law we know that V is equal to IR. But for a different resistance value, the potential difference will be, it will not be the same, it will be different. So V1, that is potential difference across 10 ohm. So V1 is equal to I. The value of I is 0.1. What is the value of R1? It is 10. So that is 1 volt. So the potential difference across 10 ohm is 1 volt. Coming to the next one. Here they have given a circuit diagram. That is, there are 4 different resistors of 10 ohm each. All the resistors are 10 ohm. but there are 4 different. It's not the same. The value might be the same, but it's like the value of each resistor is 10 ohm. This is 10, 10, 10 and 10. So this is the circuit diagram what they have given. Here if you look at this, you might be wondering whether it is series or a parallel. So in that case what you do is, the current, it starts from positive terminal and ends at negative terminal. So this will be the direction of current. So when it comes to this point, assume it is A. In A, the current splits. So if you take this as I, so here it will be I1 and I2. What happens at point A is, the current which is flowing, it splits into I1 and I2. It's only 2 paths that it can split. So there is no third path. So what's happening is, I is equal to I1 plus I2. The current is getting split. So the current I1 is flowing through this 10 ohm resistor. Here also it flows through different 10 ohm resistor. Current I1 is flowing through this 10 ohm resistor. After going here, it won't split. It flows through this 10 ohm resistor. Similarly, after coming to this point, the current is not splitting. It flows through the 10 ohm resistor. So here also it is I1. Similarly here also it is I1. I2, which is flowing through this 10 ohm resistor. So after coming at this point, that is B, both I1 as well as I2, it combines and the current I flows here. So if you look at this, or for easy understanding, what you can do is to find whether it's a series or parallel. If the current flowing through the resistor is same, then it is series. Here if you take this path, the current I1, it flows through these 3 resistors. It is the same. The same current is flowing through all these 3 resistors. So this is in series. But here at this point, the current is getting split and again it is merging here. So across these 2 points, it is parallel. Means this and this are in parallel. So if you write it, so this is the simplified version. So 10 ohm, 10 ohm, 10 ohm. This will also be 10 ohm. The value of this is 3 volt. So now you can simplify. This 3, 10. So it will be 30 ohm and 10 ohm. So this is in parallel. So if you take 1 by Rp, that is 1 by R1 plus 1 by R2. So what is the value of R1? Let us take it as 30 plus 1 by 10. So the LCM is 30. So 1 plus, if I want this to be 30, I need to multiply with 3. So 1 by Rp. So 1 by Rp is equal to 1 plus 3, 4. 4 by 30. So if I want the value of Rp, I need to take the reciprocal. Rp is equal to 30 by 4, it is 7.5 ohm. So I know the value of Rp, that is 7.5 ohm. You know what the value of Rp, that is parallel resistance. Rp is 7.5 ohm. So if I want to find the value of current, I is equal to V by Rp. So it's always better to take the expression or the terms whatever you have taken, because if you take just as R, here you have not used R anywhere. So the evaluator might be wondering, where did this R come from? You have the value of V. V is 3 volt, but what is the value of R? You have not used R anywhere. It is either R1, R2 or RP. So R is nowhere used. So at that time, so use whatever you have written. So V is 3 volt. So 3 by 7.5. For easy simplification, what you can do is, instead of writing RP as 7.5, you can write RP as 30 by 40. Sorry, 30 by 4. 4 goes to the numerator. That is 3 into 4 by 30. 1s are 10s are. So it is 0.5 ampere. So the calculation is easier when you take it in the fraction, because here it easily get cancelled. If you would have taken 3 divided by 7.5, you should have done a long division. So to simplify that, you can take fraction as it is. So the value of current that is flowing through the resistor is 0.4 amperes. Coming to the next one, there are cylindrical copper conductors along with their phase areas and lengths, which geometrical shape in the resistors. So there are 3 cylindrical copper conductors along with their phase areas and lengths as shown. The first cylindrical has the area of cross section A and length L. Similarly, the second, area of cross section A by 2 and length 2L. Similarly, the third, it is having area of cross section 2A and length is L by 2. These cylindrical conductors are made of same material. So the resistivity rho is the same because it is made of same material. So we need to find which one is having the highest resistance. So which among these 3 is having highest resistance? So if you want to find the value of resistance, you know R is equal to rho L by A. The value of resistance, R is equal to rho L by A, because you know the value of length and you know what is the value of area of cross section, and you also know that the nature of materials, that is rho, is same. So if you take the first one, if I take this as first, second and third material or third pipe, so R1 rho is the same, or R is equal to rho L by A. If I take this as R1, rho is the same, L, that is capital L. What is A? It is the same. So R1 is rho L by A. Next, R is equal to rho L by A. If I take R2, rho, the resistivity of material is the same. What is L? It is 2L. So what is area? It is A by 2. 2 goes to the numerator, that is rho 4L by A. If I take 4 common, I will be left with 4L by A. So rho L by A, it is R1. I can write it as 4 R1 because rho L by A is R1. So what is R2? It is 4 times the R1. So similarly, R is equal to rho L by A. Using this equation, R3, rho, resistivity is same. What is L? It is L by 2. What is A? It is 2A. So 2 comes to the denominator, that is rho L by 2 2s are 4A. If I take 4 common, that is 1 by 4 rho L by A. What is rho L by A? It is R1. So this is nothing but 1 by 4 R1. So R2 is 1/4 R1. So if you see, R2 is 4 times the R1, means this is having the highest resistance. So if you look at this, this is having the lowest resistance. Why? Because resistance is directly proportional to length. Resistance is inversely proportional to area of cross section. Coming to the next one, find the current flowing through the following electric circuit. So this electric circuit, what they have given, it is 3.6 ohm, it is 6 ohm, 3 ohm, 1 ohm and 3 ohm. So if you look at this, the current I is flowing here. So here also it is I at this point. So let us take it as A. So what's happening is, it is splitting I1 and I2. I2 current is flowing through 1 ohm and 3 ohm. So when it comes here, it will be I2. So similarly here it is I1. So at this point B, what's happening? Both the currents are combining. So the current which is flowing out will be I. So if I take this 6 ohm and 1 and 3 are in parallel, that is 1 ohm and 3 ohm are in series, because I2 is flowing through 1 as well as 3 ohm. So 1 and 3 are in series. This is in parallel with 6 ohm. So what is the value of this? 1 plus 3, that is 4. So if I simplify, it will be 1 plus 3, that is 4 ohm. This is 6 ohm. This is 3.6. This is 3 ohm. So 6 ohm and 4 ohm are in parallel. That is, if I take 1 by Rp, that is 1 by 6 plus 1 by 4. So what is the LCM? LCM is 12. So if I want to make this 6, 12, I need to multiply with 2. Similarly 4, I need to multiply with 3. So 2 plus 3 is 5, 5 by 12. This is 1 by Rp. So if you want to know what is the value of Rp, take the reciprocal, that is 12 by 5, 2.4 ohm. So this is 2.4. So this is 3.6 ohm. This is 2.4 ohm. This will be 3 ohm. So all are connected in series. So if I add Rs 3.6 plus 2.4 plus 3, that is 3.6 plus 2.4, 3.6 plus 2.4, 3.6 plus 0.4 is 4, 4 plus 2 is 6, 6 plus 3 is 9 ohm. So if I want to find the value of current I, V by Rs, what is the value of V? Value of V is 4.5 volt. 4.5. What is the value of Rs? It is 9. So that is 0.5 ampere. So the current that is flowing through this circuit is 0.5 amperes. So here they have given two graphs. VI graph for two wires A and B are shown in the figure. If both the wires are of same length and thickness, they have given same length and thickness. Which of the two is made of material of high resistivity? Here they are asking which material is having high resistivity. So if you look at this graph, there are two lines, that is, one is A and another is B. So they are asking which material is made of high resistivity. So if you take, this is a VI graph. So if you want to find the resistance, so resistance is given by slope, that is V by I. The resistance is given by slope. So this is nothing but resistance. So whichever slope is having higher resistance, means the slope which is tilted at larger angles will be having higher resistance. So if you look at these two graphs, A is having higher resistance. So A, that is RA, will have higher resistance. The value of RA is greater than the value of RB. That is, resistance of A is greater than resistance of B. If you take the expression, that is resistance is equal to rho L by A. If you take this expression, what they have given, the length and the thickness. The length and the thickness are same. So that is, if you take RA, it will be rho A, because it is a resistivity of material. It depends on the material. L by A. Similarly, if you take RB, it is rho B L by A. If you take the ratio, that is RA by RB, so both length and area of cross section get cancelled, so we will be left with rho A by rho B. So we know that resistance of A is greater than resistance of B. Hence, the resistivity of A is greater than resistivity of B. So whichever material is having higher resistance will be having higher resistivity. So whichever material or whichever slope is more, the resistivity will also be more. So solve some more I'll be solving some more problems related to electricity in the coming classes.